Today's lesson is about recognizing function families and their connections, including vertical shift of an absolute value function. It is student learner expectation NLF.4.A1.4. In this lesson, we're only going to look at the standard form of an absolute value function, which is y equals the absolute value of x minus h plus k. But we're not even going to worry about the value of h right now. That will be a later lesson. Right now, we only want to look at that plus k. Well, what does that k do to it? Well, that value of k is either added or subtracted on the outside of the absolute value. And what it does is it takes the graph and it shifts it up or down respectively. In other words, up if the value is positive, down if the value is negative. So let's look at an example, like y equals the absolute value of x minus 3. What have we done to the parent graph y equals absolute value of x? Well, the minus 3 causes the graph to be shifted down 3 units, just like y equals absolute value of x plus 7. What does the plus 7 do? Well, by adding 7, you have caused the graph y equals absolute value of x to be shifted up 7 units. So here's what we want to do. Let's work some examples and let's do two things. I want to determine the vertical shift, and then I'm going to graph and compare the parent function with our equation. So let's look at example 1. What shift is implied by the following equation? Y equals absolute value of x plus 3. What have we done to that parent graph? Well, the plus 3 means that we have taken that parent graph and moved it up 3 units. So let's graph the parent graph and this equation to see exactly that relationship graphically. Well, we're going to graph y equals absolute value of x, which is the parent graph of all absolute value equations, and then we're going to graph that y equals absolute value of x plus 3. So let's do that parent graph first. Well, it is always centered at the origin, so I'm going to put a point at the origin, and then the slope is understood to be 1. So I'm going to go up 1, left 1, right 1 in both directions. If I do that, it's going to make a V, and it should look something like this. Now let's graph that new equation. Now this time, because we've shifted the graph up 3 units, instead of starting at 0, 0, we're now going to start at 0, 3. But besides that, it's still an absolute value equation. It's still going to be a V. So what does it look like? Well, something like this. So you'll notice both of these graphs look identical. The only difference is our new graph has been shifted up 3 units. For example 2, we're going to do y equals the absolute value of x minus 10. What have we done with the parent graph? Well, we have shifted it down 10 units because it is negative. So let's graph the parent graph and this new graph and see the difference. So y equals absolute value of x and y equals absolute value of x minus 10. Well, the parent graph, we've done that before, so I'm just going to graph it. Now on the next one, that negative 10 means we go down 10 units. Well, if you look at my graph, I can't go down 10 units and go by 1. So what I'm going to do is I'm going to go by negative 2s. So now I'm going to go all the way down to that negative 10 and put my point. And then this is an absolute value, so it is still a V, just like the original parent graph was. So it looks something like this. So again, the graphs look identical. They're just in different spots on the Cartesian plane. Now let's do one final example. Let's do y equals absolute value of x minus 1. Well, from the parent graph, what have I changed? What is different? Well, the answer is we've moved the graph down 1 unit. So let's graph it. Let's see what happened. So y equals absolute value of x. We know how to graph that one. And we're going to graph that y equals absolute value of x minus 1. So the parent graph, again, centered at the origin. It's a V. Looks something like that. So now to graph the new one, we've got to move it down 1 unit. So from 0, 0, I go down 1. So I'm at 0, negative 1. But besides that, still an absolute value, so it still looks like a V. So you'll notice these graphs, again, they look exactly the same. All we're doing by adding and subtracting numbers on the outside of the absolute value is moving the graph either up or down. So this is what a vertical shift does to a parent graph.